Welcome to MySci Unit 11, A Home for a Penguin. This is a second grade physical science and engineering unit where students explore what components are needed to build a penguin habitat for a zoo. Let's take a look into the unit at a glance. This unit covers several second grade physical science standards about the reversibility or not of changes caused by heating and cooling, investigating the properties of materials, and determining which material is best suited to a certain purpose. Engineering standards are covered as students define, design, and analyze data on a solution to a problem. One life science standard is partially addressed on comparing the diversity of life in different habitats. Each of the next generation science standards correspond to a Missouri Learning Standard listed in parentheses on this chart. We have integrated all dimensions of these standards into the unit. If you'd like, take a moment to pause the video and review them. This unit is divided into two sections. Each section has a driving question designed to reflect what we anticipate students would naturally ask through the learning process. An anchoring problem carries through both sections. Section 1 has 4 lessons and Section 2 has 2. Overall, the unit should take about 25 to 28 days to complete. The anchoring phenomenon is emperor penguins from Antarctica are coming to live at the St. Louis Zoo, where it can get hot in the summertime. Students will explore what an emperor penguin needs to survive and investigate the properties of materials that can be used to build a habitat for them at the St. Louis Zoo. The driving question for Section 1 is, what do we need to know to design a zoo habitat? Students connect to the anchoring problem by first learning what emperor penguins need to survive. Then, students consider materials that could be used to design and build a home for the penguins at the zoo. Students investigate the properties of materials, describing solids and liquids, and how materials can change when heated or cooled. Students discover some of these changes are reversible, while others are not. Students then begin to design a zoo habitat for the penguins and test out several materials that might work as insulators. The section concludes as students choose a material to use to insulate their habitat based on evidence collected from their investigation. Through the storyline in Section 1, students gain an understanding of these standards-based big ideas. Creating a habitat that keeps the penguins cool in St. Louis can be solved using engineering. Matter is anything that takes up space, and matter can be solid or liquid. Properties of materials can be compared and used for scientific purposes. Not all materials and their properties are useful for every purpose. Heating or cooling a substance can cause changes. Some changes are reversible and others are not. Materials and their properties can be used for different purposes, and not all materials are useful for the same projects. Introducing the anchoring problem and Section 1 combined should take about 17 to 18 days to complete. The driving question for Section 2 is, how can we build a penguin habitat that works for penguins and people? In this section, students connect to the anchoring problem by continuing to engage in the engineering design cycle. They apply learning from the unit to plan, sketch, and build prototypes of their penguin habitat designs. Students then work in groups to test their habitats under the heat lamp and analyze the results. The section concludes as students compare their solutions and outcomes and use evidence to make a claim on which solution works best. Through the storyline in Section 2, students gain an understanding of these standards-based big ideas. Before building an idea for a solution, people can use sketches to plan and communicate their ideas. Because there is always more than one possible solution to a problem, it is useful to compare and test designs. Section 2 should take about 8 to 10 days to complete. Our team here at MySci hopes you and your students enjoy being engineers to design a home for a penguin, and we look forward to your feedback. Happy MySciencing!